Okay, welcome everyone to this joint webinar between Rebaca Technologies and Aarna Networks. Today we're going to talk about streamlining and validating ORAN interoperability testing. Today's speakers, I'd like to introduce Samit Ghosh, Senior Architect from Rebaca Technologies, and Sriram Rupanagunta, Co-founder and SVP of Aarna Networks. Just a quick housekeeping item. Slides for this webinar will be shared to all the registrants after the fact, so no worries about that. We also encourage you all to ask questions of us throughout the webinar using the Q&A function. And without further ado, let's get started, and I'll turn things over to Sriram.
Thanks, Brendan. Hello, everyone. So let me start with the overview of the ORAN. So as some of you may already know, the ORAN space is now disaggregated, and there are multiple vendors who are going to be supplying the components. So this has necessitated interoperability testing because these components will come from different vendors. So the ORAN Alliance has created a very detailed interface specifications for ORAN. So the components have a standard way of interfacing with the other components. So now the MNOs or the vendors, the academic organizations, whoever want to test it, have a challenge, right? So the challenge is that there are multiple vendors. It's a complex system. How do you set it up? How do you run it? So that's the challenge that we want to address. Yeah, Brandon, if you can go to the next slide. All right, so the problem statement is that how can the users get started? So the first issue is finding the SMO, which is the management component, the management and orchestration, and then the radio unit, the distributed unit, the centralized unit, the RIC. It's a very time-consuming and expensive proposition, getting all of them, installing them in the lab. So the other challenge is that even if you have all of these, it's not clear if all of them will work together, if all the ORAN standards are being met, and how do you make sure that they're interoperable. So these are all the challenges that we see today. You can go to the next slide. Now, what's the solution? So what we are offering is a comprehensive ORAN stack validation. It's a combination of the ABot from Rebaca Technologies and AMCOP from Aarna Networks. So this essentially provides a standard compliant test environment and a test suite. So one of the features is that it's essentially cloud-based, which means that you will only pay as you go. So you don't have to get everything in your lab and install and incur the costs. So it's only a pay-as-you-go type of a setup. It has automated validation of the complete ORAN stack. We will show you in the webinar how that can be done. And then there's a lot of the debugging tools, execution artifacts, analytics reports, and again, Samit will walk you through all of that. And it also enables you certification for compliance to 3GPP and ORAN specifications. So that's essentially the solution that you're going to see in today's webinar. Yeah, we can go to the next slide. Yeah, with that, let me turn it over to Samit to walk you through the remaining presentation. Samit?
Thanks, Sriram. So like Sriram was mentioning, we're bringing a package that contains a way to test the ORAN infrastructure and a package that helps you get started very quickly. So this contains the CUDU and the simulators for all the interfaces that are relevant to ORAN. And it's compliant with the standards that have come out as recently as October 2022, which is the last release when the ORAN community made. And you can see that we've tried to bring the complete disaggregated solution with all the components. So if we go to the next slide, what would you do when you have all of that available to you? What would you do if you have all the components of the stack? We are giving you the ability to contact us and set up your environment, and then pay as you go as you use the environment. So in weeks and months of waiting for testing and getting your lab set up and getting approvals and things of that nature, what we're saying is that, you contact us, as it will be apparent when we show you the demo, and you install the lab in your premises or in some location that's close to you, or maybe not close, maybe even AWS. And we're giving you the facility to do this very quickly. So you can set up your lab, and going through our tutorials and resources, you will be able to, rapidly get an environment to test ORAN workloads. So this is the aim of the whole package and how to use the package. If we can go to the next slide. So what are we trying to do overall with the packages is that we're trying to bring you what the ORAN software community and what the ORAN standards community are setting as standards. So you will be able to do basic sanity tests for CU and DU. And these sanity tests are based on test cases that are formulated by the ORAN standards. You will be able to do even advanced test cases like the E2 area, which is for near real-time rig operation, and to be able to make decisions faster than radio capable handover and things of that nature. And then you would also be able to do configuration management through the O1 interface, and use the test tool as well as an SMO as provided by Aarna Networks. And using this combine, you're able to test the length and the breadth of the whole ORAN space. So this is what we're trying to do with this solution. And if we go to the next slide. So this is the pictorial view of how the whole setup would look, given all the packages that we're proposing in this solution. And for those who are familiar with the disaggregated RAN and the ORAN space, this is a standard diagram that is functional. All of those interfaces that you see, F1, E1, E2, and O1 are available. And very soon we will also have O2, which is still going through standards revisions. But that gives you, pretty much everything you need to be able to test the disaggregated RAN. So ABot, which is the test tool, AMCOPs, which is the Aarna Networks SMO, and all the components of ORAN that are provided by the test tool in combined with the SMO are available to you with this package that gets you started very quickly. You can go to the next slide. Okay, so I hand it over to you, Brandon, so you can show us a glimpse of the demo.
Okay, great. Thanks, Summit. Let me just stop sharing and I'll re-share the video file. Just a moment here. There we go.
Hello everyone. On this demo, we'll be going through the installation procedure for Aarna Networks multi-cluster orchestration platform, which is called as AMCOP. On this demo, we'll be following the operator-based installation for the AMCOP setup on your target machine. As we can see, this procedure follows the Kubernetes commands to install the AMCOP. So the prerequisite here will be you should have a Kubernetes cluster up and running for installing the AMCOP. Other prerequisite like system configurations, you can refer to the quick start guide to get the configuration needed for the AMCOP installation. We could see that now all the ports have come up and also on running status. As part of this AMCOP installation bring up, in the AMCOP system namespace, there will be 28 ports will be getting started, and one port will be starting on AMCOP operator and AMCOP storage namespace. So now we are good from the ports point. All the ports are started and on running status. So let us verify the services as well. So kubectl get services. So all the AMCOP related services will be in the AMCOP system namespace, and we could see all the component services are successfully started. For the SMO service, the service will be SDNR, and it will be accessed over 30181 for HTTP and 30443 for HTTPS communication. So let's go ahead and see how to access the SMO UA. So we'll refer to the user guide for accessing the SMO portal. So here we have a session called steps to access AMCOP SMO portal. Go to that page, and this is the URL for the AMCOP SMO. So AMCOP SMO is a web-based UA where you'll be using your browser to log into the SMO. So here these 192 series IP, it will be your VM IP, and you need to replace it with the respective your VM. So let's copy paste this URL here, and okay, and replace it with the VM IP whatever you have. So IP space A. So my VM IP is here, ENS3 192 168.1.244. So let us change it here. we are good to log in to SMO. So similarly, you can log into the SMO with the HTTPS credential as well. Which will bring up the HTTPS web page for the SMO. So on the SMO login page, enter the credential on the user guide provided. So it's admin, and copy paste the user credential there. So admin login. Even the HTTPS will have the same login credential there. So as you can see in the left pane, the console pages are available here. We have the different options like connect, fault, maintenance, configuration, and other UI pages available. So the connect page, where you will be adding your network elements, your respective RU, DU, or CU node, you will be adding here with the details like IP address, provided the port details and the credential to log into the device. So once you added these devices here, on the configuration page, you can basically see all the device configuration here. The device name will be shown here, and the loaded configuration for the device will be available in the UI. So that's all basically on this demo. We are end with the demo for the AMCOP SMO installation. Thanks for watching.
The installation of ABot can happen using the following steps. First, the user needs to install a Ubuntu server version 18.04. Then one needs to register oneself in the ABot Rebaca portal and then receive instructions by which the user is facilitated to install the ABot program. And once done, the user must ask for an ABot license in the same customer portal. In order to install ABot, one must visit the customer portal abot.rebaca.com. Once logged in, the user is presented with the option to request for ABot evaluation. Once you press the button for ABot evaluation, our customer team will get back to you with further instructions. Once the user becomes an evaluation customer, they are given the option of the support tab in the customer portal. Upon selection of the support tab, one can raise a support ticket to request for an ABot license. Once the user receives the instructions by mail, it shall contain links to the download locations of the ABot software. It shall also contain an instruction manual, and inside the instruction manual there shall be dimensions of the virtual machine on which the software will run. Once the software is installed, one can access the graphical user interface by accessing the IP address of the virtual machine using a browser. Let us now understand how to configure ABot using different test beds and different SUT variables. The ABot feature files consist of call flows that are written in a high-level English-like language. Each call flow consists of grammar that uses a given, when, then construct. Given is a precondition, when is an action, and then is a verification of the action. There is a smart editor that helps the user write the grammar, and the grammar refers to elements in the configuration. The variable parts of the grammar can be filled using the smart editor autofill options. The ABot configuration is an intelligent organization of key-value pairs that are arranged in a hierarchical manner. The configurations are mainly classified into three areas: test beds, SUT variables, and SUT scripts. By arranging multiple versions of the above hierarchically, the user is able to select different versions of these elements and create customized versions of their own from the same. Let us compare two separate testbed configurations to understand the hierarchical configuration. The first testbed is an all-emulated configuration. Each of the nodes referred to in this testbed are emulated by ABot, and hence they are mentioned in a comma-separated key known as the ABot simulator names. Notice that the ABot SUT names key is empty. The second testbed configuration consists of nodes that are real as well as emulated. These are then mentioned in the two different keys. Notice that the mother configuration file has the capability to select between the two different testbeds. A similar thing happens with the SUT variables, which are used by the feature files in order to run the test cases. Notice that in this case, again, the ABot mother configuration is able to select different SUT vars from the different hierarchical configurations. In the end, what we see is that the feature files refer to these configurations, whether they are testbeds, whether they are SUT variables, or whether they are scripts. The feature files refer to them, and hence need not be changed every time we want to run the test cases in different environments. Let us now see how simple it is to run a test case using ABot and the Aarna AMCOP's SMO. We shall configure ABot to use the SMO IP address and the RESTconf port and run the existing test cases. Configuring ABot to work with the Aarna AMCOP's SMO is a simple two-step process to begin with. First, you change the SMO IP address and RESTconf port in the hierarchical config, and then select the OCloud config in the mother configuration. We're now ready to execute the test case using ABot against the Aarna AMCOP's SMO. The following test case is to test the startup conditions of a device connected through the O1 interface using the Aarna AMCOP's RESTconf interface. As soon as we hit the play button, we see the multi-site test case executing. And as we follow the log, we see the execution of the steps. Once the test finishes, one can review the artifacts. For example, the packet capture containing device capability. Let us now use ABot to run test cases for the F1 and E1 interfaces in an all-emulated environment. Configuring ABot to run these test cases is again a two-step process. First, you configure the nodes with the appropriate IP addresses and ports, and then in the mother configuration, you select the appropriate testbed and the appropriate SUT-vars. We are now ready to execute the UE initial access test case using the F1 and E1 interfaces in order to register the UE with the core network and the access network. Once the test case finishes executing, we can analyze the results using the familiar ABot user interface consisting of graphs and packet captures.
Okay, great. That was our recorded demo. I'll hit stop sharing and then I'll go back to our slides. There we go. And just as a reminder, while we finish up these last couple slides, please feel free to put any questions you may have in the chat window, the Q&A function, and we'll cover those at the end. All right, turn it back over to you, Sriram.
All right, thank you. So now coming to the combined solution that we talked about with AMCOP and ABot. So what's the value proposition? So the first one is it's a no-code automation. So the automation engineers only need domain knowledge So they don't actually need to code using any of the programming languages. And no code generation tool required. So there's a smart editor, which you saw in the demo, that enables you to author these test cases. And there are all these pull-down menus with 3GPP, messages, interfaces, and so on, which you saw in the demo. So essentially, it means that a lot of these tests can be run if you have the domain knowledge. You don't really have to be a programmer to run these tests. The other advantage is that it's a very comprehensive environment. It has a 5G ORAN, network functions, RIG, and SMO. It has extensive support of a bunch of ready-made 3GPP compliant test cases. And there are test cases for functional, interop, performance, and traffic modeling, various types of traffic generation, including video traffic. And it enables you to onboard the new protocols and interfaces very quickly. And lastly, the cutting edge technology support like MEC, split RAN, and dynamic network slicing. So these are some of the value propositions. And Samit, maybe you can cover the other two.
Sure, Sriram. So apart from the things mentioned at the top, we have the capability to do CI/CD and CD. So what that means is that along with the graphical user interface and ways to analyze information, we have extensive REST API support that can be integrated with any CI engine. Deployment characteristics of both the solutions are cloud native, hardware agnostic, and can be deployed in virtualized platforms or K-test clusters or AWS clusters. It has a variety of deployment mechanisms. You can automate your testing with the help of integration with the CI engine, and use a very large set of test cases, which run into the numbers of about 400 or 500 test cases. And then we have analytics support, which can do root cause analysis. It can show you KPI, and it can also do trend analysis and maturity of the software that is being tested. All of this is supported with graphs and very intuitive user interfaces, so that one can dig down to problems that one sees while testing all these telecom workloads. So we can move on to the next slide, and Sriram, if you would like.
Great. Thank you. So here are some links to learn more about what you've seen here today. As a joint effort between Aarna and Rebaca, we have information available on both websites, as well as ways in which to contact either company to get your questions answered and to get started with trying out this solution. Also linking to a joint solution brief we developed that has more information about the solution. So as we move into the Q&A portion, I will copy out all these links and I'll put them in the chat window, so you'll have quicker access to live links where you can learn more. But as mentioned, feel free to send us your questions here. We'll try to answer as many as we can here live as well. So the first question coming in is about the SMO. Does the SMO, is it fully compliant with netconf-based interfaces?
Yes. Yeah. So it's fully compliant with netconf interface. In fact, it's been validated with the simulators as well as the third-party vendors on the NetConf interface.
Okay. Thanks for that, Sriram. Also, what makes this ORAN test framework stand out compared to other available ORAN test suites on the market?
Sure. So I'll take that one. So the biggest problem that is there in the test arena is the ability to integrate new features quickly and to be able to do test cases in a very short period of time, and to be able to hyperscale the test cases and be able to do this in different environments. So if you compare the solution that we have put together with other test tools in the market, the advantages that we propose are the ability to test new features quickly and to be able to integrate new features into production environments very quickly, and to be able to generate test cases to test these new features using an interface that is intuitive and conducive to rapid test case development.
Great, thank you. Is your platform running on AWS?
Yes, the ABot platform is capable of running on AWS, and Sriram, I believe the Aarna platform as well.
Yes. Yeah, it's been validated on AWS, and yeah, you can install both AMCOP and ABot and run your tests on AWS.
Okay. That's great. Next question is, the demo is showing AMCOP installation and SMO GUI access. Is the AMCOP SMO GUI needed for running these tests from ABot?
Okay, so let me take that. So what you saw in the demo is AMCOP installation, followed by accessing the SMO GUI, AMCOP SMO GUI, followed by the ABot installation, and then running the tests, right? So for running the test through ABot, you don't really need to use AMCOP GUI. So the AMCOP GUI is, if you're trying out something manually, adding devices or even in an automated way, but it's not something where you can run all the tests in an automated way. So in order to run the tests that were shown in the demo and in the solution, you will be driving them through the GUI provided by ABot. So you don't have to use the SMO GUI.
Okay, gotcha. Is there a comprehensive training available from installation to some sample tests?
I can take that, Sriram. So yes, there is comprehensive set of documentation as well as videos that help you get started very quickly. And all of those resources are available at our customer support portal. And if you navigate using the interface over there, you should be able to start very quickly.
Okay, great. So here's a question about speed of getting this going. So how fast can this test framework adapt to different test topologies? How fast can the test suite be scaled up to validate different new test requirements that may come up during the test cycle?
Sure, I can take that. Yeah, that's one of the key benefits of this solution, in the sense that it is completely configuration driven, and the configuration, the way it is organized, helps you switch to different environments, and those environments could be different telco parameters. For example, you could be running in an environment where there are frequency bands that belong to a particular range. There could be other trivial parameters like the MCC and MNC that need to match to a particular number, or there could be other functional mobility related characteristics that can be defined in a configuration file, and those configurations are then used to drive the test cases. So that reduces your time to actually adjust the tool to your test environment, and it sort of helps you keep multiple possibilities of environments while you're doing the testing. So that is one of the key benefits of using this solution.
Great. And see a lot more questions coming in. This is great. Somebody says, I remember seeing RUSIM, RUSIM, mentioned in the initial slides. Does it support a 7.2 split option supporting the front haul C plane, U plane, and M plane, or is it only M plane supported?
Yes. So the RUSIM that we suggest in the slides are provided by the Aarna SC community, and we provide the capability to do the M plane testing of the RUSIM.
Okay, great. Does Rebaca, or can it be integrated with both Dockerized and Kubernetes Helm-based SMOs with regard to PCAP?
Yes, this is possible. We can work with a hybrid nature of installation where you have virtualized components as well as cloud components, and we can have a pure cloud environment deployment as well as pure virtualized deployments. And yeah, PCAP extraction and analysis is one of the key things, or the key features of the tool, in order for you to make inferences about root cause of problems.
Okay, great. How much AMCOP in Rebaca does in line or do in line with 3GPP ORAN standards? Are they compliant to the latest standards or still lagging behind?
So I can maybe cover the SMO part. So that as far as SMO is concerned, we are pretty much compliant on the O1 interface. The O2 is still a little bit behind. It's not fully compliant with O2. That's something that we will be adding in the future. And same with the A1. So those two are a little bit behind. But O1 is fully compliant, and we have done the validation with other third-party vendors and also in the other interop labs like TIPROMA and I14Y and so on. So I think that's as far as SMO is concerned. So maybe for the tests and the ABot, Samit, maybe you can answer that.
Sure, Sriram. So like Sriram was saying, that the compliance with the O1 and the compliance with the northbound RESTconf, ABot is capable of doing those in the SMO and orchestration area. And in the functional 3GPP area, we support the ORAN workgroup 5 kind of testing, which is the F1, E1, and also the workgroup 3, which is the E2. So those are the ones that we currently support and are compliant with the 3GPP as well as ORAN standards.
Okay, great. I think we probably have time for maybe one more question. Can I replace the CUDU simulators with vendor-provided functions?
Yeah, I can take that. Yes, you can certainly replace the CUDU simulators that are there in the package with the CUDUs that you may have from other vendors, and in fact that's the whole purpose. So you can still run all the tests using ABot and make sure that the vendor provided CUDUs are compliant going through the SMO. So yeah, the answer is yes, you can certainly replace them with the other CUDU.
Okay, great. Well, I think that takes us to the end of our time, and great discussion here that we've started around this topic. As mentioned before, we will get the slides and the video recording out to all of the registrants here shortly. Very much appreciate you joining us here today on this topic. If you want to learn any more or contact us, please go to each one of our websites, and in the email that we send out with follow-up information, you'll see those links as well to get easy access to our web areas and the solution brief where you can learn more. So with that, I think I will wrap it up. Thank you very much to Samit and Sriram, and wish everyone on the call here happy holiday season. And we look forward to speaking with you again next year.
Thanks a lot, Brandon. Thanks, Sriram, and thanks everyone for joining.
Okay, thank you. Thank you, everyone.
All right. Take care, everyone. Thank you.
Bye.